Okay, hello everyone. Now we'll explain the three processes: isobaric, isothermal, and isochoric processes. But I will explain the work done by these processes. So, for example, first of all, let's take isochoric process. Isochoric process is a isochoric process is when the volume is constant. So we know that the work is equals to P delta V. Plus minus, it depends on the expansion or compression. So, but here we know that delta V is a V final minus V initial. But since the volume of the gas will remain constant, the difference from final and initial volume will equal to 0. So here we can find that work done by isochoric process is equals to 0. No, I explained by formula, so I can also we can also find it by the graph. So here also the next process is let's take isobaric process. In isobaric process we know that P is constant. P is a pressure, yes? So here we know work done is equals to P delta V. So delta V dV. It's a differential. So here if we take integral, work will equal to P integral P delta V from V initial to V final. And here we know that P is a constant. P will go out of integral, and here the integral for delta V is V final minus V initial, yes? V final minus V initial. And here we'll find that it equals to P delta V. So plus minus, it depends on if it's compressed, it will be minus. If it's expands, it will be plus. So third is isothermal process. In isothermal process, in isothermal process, we know that that temperature is a constant, and also here the work is equals to dV, so P dV. But in here P will change and V will change. So what we will do? We will when we will take integral P delta V, we will write P like from ideal gas formula, like nRT over V. And so here from the initial to the final, So here T is a constant and nRT is a constant, and here it will go out of integral nRT in integral delta V over V. So we know that delta V over V from integral is like nRT multiplied by, it's a ln V final minus ln V initial. So this will be our third equation. So thank you for watching and goodbye.